Hello again, YouTube. The last time I looked at this development board for the NXP, the LPC1769, which is this OM13085. So I just used that as an example just to look at some libraries of code. So this is some open source libraries. So this was our development board. The development board on the right and the debug on the left. So I want to do the same again, just to look at a different set of libraries, to have another example. And this time I'm going to look at this little device, which is it's by a company called 1BitSquared, and it's a 1Bitsy. So it features basically this STM32F415, which is a lot of people are using STM32s. So with that there's a Libopencm3, which is a library that's often used. So just to have a look at that library of code, I just want to look at this development board. But it also has that company 1BitSquared also do this Blackmagic probe, which is a little JTAG programmer. So you can actually use it's got a GDB server on it, so you can step through code with GDB, and this is it. So between the two of them, I mean, it's a very small kit. You could carry it around in your pocket, obviously in a case or something, so you didn't damage it. But yeah, if you wanted to program up some ARM assembly or whatever, actually I'll link to some ARM. There's a good set of blog posts on ARM assembly. So all you need is these two devices and two micro USB cables, and you're good to go. So I'm going to look at that and doing what we did the last time, which is doing this interrupt routine to drive our hello world. So the quick start guide gives you details of installing the GCC ARM toolchain. You're going to need that, obviously. And there's also a set of examples. So I've actually forked that set of examples because I'm about to write an example using a timer to interrupt, because there is no example of using a timer. So I'm going to I'll contribute this back, and if it might not be of any use to anybody, but you never know, because I don't use Libopencm3 very often. I might struggle with this, but we'll clone into this my fork and start messing about. In the meantime, this device that we're looking at, this is the reference guide. So the last time we looked at an LPC1769, which is based on an ARM Cortex-M3, and this time, and it was 851 pages of a user manual. This time the reference manual is 1745 pages long, and it's based on an ARM Cortex-M4 with FP floating point unit as well. So it's a bit of a chunkier manual, and I want to start looking at the timers. So that's an advanced timer. Not really too bothered about advanced, so I'll use a general purpose timer and go through this. So these are all the features, not too bothered. Block diagram. So we have an auto reload, which is good. So if the auto reload is reloaded after every timer expiry, and then there's an update event. And that update event is what we will use then to fire an interrupt. So getting into this counter modes, if we just use up counting mode, before I get into that, let's get into these examples. Now you've got to initialize. If you actually try and make it, it'll tell you what you've got to do. You've got to initialize a module. And update. So if I now do make, that's us. And just before I start making changes, I'm going to check out. Now I'm using timer 2. I'll use timer 2. It's timer 2 to 5. So I'll just use timer 2. And call my example blink. Timer 2 blink. The other thing I'll do is I use Emacs, and I'll generate a tags file for all the code underneath this directory. So that should set up a tags file. So if I go into examples, 1Bitsy, and I've got a few examples there, and I'll just copy the fancy blink as a starting point and copy that to timer 2 blink. Let's check it. So sorry, all fingers. So, quick readme, make file. Now I'm not going to change a lot, so I better leave that as it is for the rest of it, and then my binary is just going to be timer 2 blink, and the linker script. The only thing is, if I move fancy blink to timer 2 blink.c, I should actually be able to make now. Yeah. So, where do we start? once again, I'm probably going to it's in reverse order. I'm going to build on top of this code. I'm not actually going to start from scratch. So, where to start? The documentation is as good a place as any to start. So if I go back to and cd doc, I'll check that this is made up to date, so I'll make the HTML. There's a bit more documentation in this than there was for the LPC, by the look of it. So then if we look at it with Firefox, right, sorry. So that's the directory I'm in. So back to the documentation. Now this library, you can see that there are a number of chips. Actually the LPC 17 is there, but there's not a lot. There's GPIO and power seems to be all that's included. And for the STM32F4, there's a lot more functionality. So if we look at the timers, this is the API functions that we've got to use. But let's start by looking at another example, hopefully one that uses an interrupt. So USART IRQ. So if we look at that C file as an example, now it sets up obviously a lot of stuff that we're not going to use, but it enables a peripheral clock. So we want we want to be able to do that. So we'll have to enable a peripheral clock for and not for that device, but for our own device. So we'll just I'm using Alt dot all over the place just to jump to tags, and I created the tags up in 1Bitsy examples. So we want to enable timer 2. So that's the first thing. And then we can actually reset the timer. Timer reset. So we know we're starting from a and it takes a base address, which is I wonder, can I use Tim or Tim2 or Tim2 base? Same thing. Input parameters, timer register address base. Tim2. Try Tim2. TIM2. Actually, TIM2 and timer reset, I'm not including timers. So timer.h. Yeah. And it's happy with TIM2. So we reset the timer. And now if we go through the actual documentation, well, if we go through this list of functions, now these are quite a low level of function. The API functions are quite a low level, so it's actually hard to see what I suppose set mode is we certainly have to set and we have to set clock div we won't divide just keep it simple. Alignment, again, let's keep it simple and just go with an edge. And the last parameter is a direction, so a count up. So that's the mode. So we have to set a prescaler and the auto reload. So there should be an API function for set prescaler, set prescaler, set prescaler. Actually sets prescaler and set period. So it's value. This prescaler is a 16-bit value. Set prescaler. We'll just choose a hash to find for the minute. And in the same area was set period, which I assume is, yeah, it's the auto reload register. Set period, period. So those two, if we keep this simple and we just go for if we go for 1 pulse a second, now this is 168 megahertz. So we've got prescale and period. And because we've got 100 and Sorry, just hit my caps lock. I think if we're going to have a 1 second interrupt, I want prescale times period to equal 128 meg, and I said that the prescale is a 32-bit value. Sorry, prescale is a 16-bit value. Right. So if we use a calculator for, so 128, no, what did I say? Where did I get 128 out? It's 168. If we divide that by obviously 10,000 for a start. So if we've got 10,000 and 168, just correct this comment for a start. 168. If I set the period to be 10,000. Actually set the period to be 16,800. And set the prescale to be 10,000. Just to check. Yeah, that both of those will fit into 16-byte values, so that should be 1 second on. So set the prescale. Is that prescale or prescaler? Prescaler. I've got too many L's. Prescaler and period. And back to the documentation. We want to go up counting. So we've set the AAR. The update event is generated by the UG bit in the EGR register. Timer 2, so I want to set EGR register dot UG bit is equal to 1. Now that's what I would do in bit field, which is how microchips code works, but I need UG bit. Update event. Oh, I don't want to disable it. Hold on a minute. Enable update event. That seems to be setting something different. That's a UDIS. I'll just check it. If I just alt dot to that, yeah, that's setting, that's clearing a UDIS. That's actually CR1. That's setting a UDIS update event. What did I say? The UG. Sorry about this. UG bit update event. That is just to get into libraries. I'm not sure this is actually doing anything other than obscuring what I want to do. Probably the easiest way to find this, I want to set the UG bit in the ERG. So if I search for UG, there it is. Well, it's setting the EGR register. So I want the timer generator event function. See, that's my problem with it's kind of obscuring. The library's kind of obscuring rather than helping. So if I go to generate event, that's it there actually, it's right beside it. I want to set event values, and that's me, UG. So these comments on the right is what I would usually do a microchip, and these functions obviously basically set bit fields. So they're using bit fields to OR bitwise operations to set bits, and I'm not sure why that is deemed. I must actually write a blog post on that. That to me, this function, timer generate event, and the actual documentation, the library isn't segregating me from this documentation. I still have to read this reference manual, but then it's kind of obscuring what functions I have to call. Yeah, I'm not sure about this, but I'll moan another day. I'll do a blog post. So back to the documentation. We've got the UG bit. So the UG event can be disabled by setting UDIS. That's the one we just did. Just check that that's set to. So set to disable. So we want it set to 0. Just check that that function is. Yeah, it's setting that bit to 0. So happy with that. So UDIS bit. In addition, if the URS bit is set, setting the UG bit generates an update event, but without setting the UIF, which will be the interrupt flag. So we want to make sure the URS bit of CR1 is 0. So if I set let's say URG, and again I don't know whether that is going to be kind of obvious from these. URG bit is URS bit, sorry, update request. Enable update event was the one we've already called. Update event request. Sorry. What? No, the easiest thing is searching through code. URS bit. If you want to find the URS bit. Right, update on any. So we want that set to 0. That's setting it to 0. This was maybe a bad idea. Auto reload, set the timer, preload, auto reload. And those diagrams are all good. And then we're into down counting mode. So that should be pretty much all we need. Now the only thing we need to do is enable the interrupt. So it must be an enable interrupt. Enable IRQ, and the values are enable. Now I wonder about what else. It didn't say anything about continuous mode. I want to keep this going forever. So I don't see anything. Set continuous mode. I assume we're going to need to set continuous mode. Let's just see, is there anything else that... There's a disable preload. So I assume there's going to be an enable preload. I better stick that in. Yeah, so on the update event we want to preload. So we'll call that one as well. And I think that must be pretty much it. We obviously want to enable the counter to start timing. But we need to enable the interrupt as well. So the interrupt, we have enabled that interrupt in the timer module. But if we go back to the example we were using from the US USART, we need to enable the interrupt there. We'll have to enable the interrupt in the interrupt module. So we don't want to enable this, we want to enable no, we've got the wrong. I think must have got that for the wrong processor. My tags file is pulling in from I'm not sure which. Let me see. TIM2. Actually, we'll just check that. Yeah, we haven't got the interrupts header file, so that's that header file. Yeah. So the other question is we need an interrupt service routine, and that yeah, these are down here. So we want an interrupt service routine for timer 2. I usually stick interrupt service routines at the top, so if I do so now all we want to do in the interrupt service routine is toggle the LED. So our main is going to do nothing. we want to toggle our lead if the flag is set and clear that flag. So get flag. Interrupt source. Yeah, I think maybe this is the and our interrupt source should be this update flag. Check that. Yeah, it returns true if the specified flag is set. So if that flag is set, we want to do clear the flag. Timer clear. Timer clear. And again, that takes the status register flag. So that should be exactly the same. Now the indentation is not to my liking. And that should be it. So I'll just no. Oh, it's just an unused variable. Sorry. So now I want to put this into, if this is going to work, I need 2 micro USB cables. Oops. That's the Blackmagic probe. And this is the 1Bitsy. So now I want to go to, now the video has the 1Bitsy quick start video. That video has the basically that what I'm going to do now, which is fire up the GDB, and we want timer 2.elf and the target. So that's the driver there, or sorry, that's the device. So if we attach to 1 and load the code, I'll set a break point from main just to, and run. Start from the beginning. So actually, if I minimize this a little, and always on top. If I continue execution, I'm not sure that's a second, but it's roughly, I mean, you could stick a scope on it and check it, but yeah, that's more or less what we're trying to do. So back to the code, is that this, I'm just doing this because I'm looking at libraries of code. So I'm not sure, as I said, there seems to be a bit of a, people frown on bit fields, but to my mind those 3 lines on the right set in the bit field is more, yeah, you've got 3 function calls on the left, and maybe the compiler's a bit more optimized for bit manipulation in that regard, by ORing and ANDing. You're still making 3 function calls, so you're putting things onto the stack, popping things off the stack, setting up return addresses and all the rest of it. Yeah, I'm not sure. And as for these functions, because they are just setting and getting values, I'm not sure it's adding anything to your ability to work without this reference manual. Opinion, it's my opinion or whatever, I don't know. But yeah, we'll leave it there. That's a look at libraries of code, and I'll then go through some of the libraries that I have for the cinnamon bun and see the difference and compare. Thanks a million for watching. Sorry this was so long. I'll try and contribute that project now back to the GitHub and see is it accepted. See you again soon. Thank you.